7.2, multiplying polynomials. So here I have two binomials, but we're not multiplying these, we're subtracting, right? So sometimes I see people use the FOIL method, which I'm going to get into in a second on a problem like this. But you only want to do that if you're multiplying two binomials together, like these problems at the bottom of the screen. Okay, so when we're adding or subtracting, first you want to write it without parentheses, and in this case it means you'd have to distribute the negative to that second binomial. So without parentheses, 2x plus 3 minus x plus 1. Right? The opposite of negative 1 is positive 1. And then I would combine like terms. So those are like terms. 2x minus x would be 1x. And then the 3 and the 1 combine to 4. So this would be x plus 4. So just a little review on that. Don't use FOIL when you're adding or subtracting two binomials. You want to use it when you're multiplying binomials. And it can only use this for binomials. So I know that's why some teachers avoid this method, because it's only for this specific scenario. I've got a binomial times a binomial down here, and the same thing down here. Okay? So FOIL is an acronym. It stands for first, outer, inner, last. Okay? And this isn't the only method you can use. You can use the distribution method or the box method. But let's talk about FOIL first. It's the most popular method for multiplying binomials. So it's usually what I use. So what I'm going to do here, I'm just going to write out FOIL, and I'll space that out a little bit. Okay, so when we say first, we're going to multiply together the two terms that are in the front of their respective parentheses. So I'm going to do 2x times x. So 2x times x is 2x squared. Okay, and then outer means I'm going to take the two pieces on the outside. So I'm going to multiply these together then. So 2x times negative 1 is going to be negative 2x. Okay, and then I'll do the inner. That means the two on the inside. So 3 times x is 3x. And then last, I'm taking the two pieces at the end of their respective parentheses. So that would be the 3 and the negative 1. And I'm multiplying those together. 3 times negative 1 is negative 3. Okay, and these are going to be all the terms. So I need to put in a plus here to separate those two terms in the middle. Okay, and then I'm going to combine like terms. So there's only one x squared term. There's only one constant, but we can combine these two terms in the middle here. Okay, so negative 2x plus 3x would be 1x, and I still get the negative 3, and there we go. Okay, and usually you'd put this in standard form with the highest degree term first and the lowest degree term last. Okay, all right, so the distribution method, you could distribute the 2x into both of these, then distribute the 3 into both of these. And that's totally fine. It's actually the same thing. That's what we're doing when we're foiling. It's just a way to keep track of all the pieces so you don't forget any of the distributing or do any of the distributing twice. Okay? All right, so let's try a couple more here. This will qualify for FOIL because it's a binomial times another binomial. So first, I'm doing x times 3x. That would be 3x squared. Outer, x times negative 5 would be negative 5x. Inner, negative 4x times 3x is negative 12x. And last, negative 4 times negative 5 would be positive 20. Okay, and then I need to combine like terms. Those two in the middle I can combine again here. So negative 5x minus 12x would be negative 17x. Okay, just some more examples here. So foiling again. So 2x times 4x, those are my firsts. That would be 8x squared. And then I'll go outer. So 2x times 6 is 12x. Inner, negative 1 times 4x is negative 4x. And then last, negative 1 times 6 is negative 6. Then I'm going to be adding up all these terms. So let me put in a little plus there. I've already got the minuses to separate the other two terms. And once again, we can combine those two terms in the middle. 12x minus 4x would be 8x. And there we go. Okay, one more time here. First, 3x times 4x, 12x squared. Outer, 3x times negative 8 is negative 24x. Inner, negative 7 times 4x would be negative 28x. And last, negative 7 times negative 8 would be positive 56. And I still want to combine those, so let's see, that's going to be negative 52. So 12x squared minus 52x plus 56. Okay. All right. FOIL can only be used when multiplying two binomials. So it's not going to work on these problems because I've got a trinomial here for the second polynomial. Same thing over here. Okay, so we can't use the FOIL method. And there are different things you can do here. You could distribute the 2x into all three terms, then distribute the 3 into all three terms, and then add up all your terms and combine like terms. That's totally fine. I like to use what I call the box method. So I'm taking this binomial and putting it on the left side here. So those are the two terms from the binomial. And then on the top, I have the 3 terms from the trinomial. And then I'm just going to think about this like a multiplication chart. So I'm going to, in the top left square here, I'm going to do 2x times x squared. 2x times x squared, that would be 2x to the third, right? Because there'd be 3 x's all multiplied together, and the 2. All right? And then in this square, I have 2x times 2x. 2x times 2x would be 4x squared, and then 2x times negative 4 is negative 8x. So really what I just did on the top row here, I distributed the 2x into all 3 of those terms. Now on the bottom row, I'm going to distribute the 3 into all 3 of these terms because I'm doing 3 times x squared. That's 3x squared. 3 times 2x is 6x. And 3 times negative 4 is going to be negative 12. Okay? So it's just a way to keep track of all of the distributing you're doing. And the nice thing about this method, you could use this even if your first polynomial had 17 terms and the second polynomial had 38 terms. It doesn't matter. You just make a bigger multiplication chart. And then you can keep track of everything. Okay? And all of these numbers I wrote in the boxes, now I'm going to add those all up, and that's going to give me my answer. So I've got 2x to the third. I'm kind of looking for like terms. I'm going to put them next to each other. Often, not always, but often the like terms are kind of on these diagonals. So I've got a 3x squared and a 4x squared. I'm putting this in order from highest degree to lowest degree as I go, too, because I know I'm going to want to do that eventually. Then I've got a 6x and a negative 8x. And finally, the negative 12. And then I want to combine the like terms. I got 2 sets of like terms there. So 2x to the third, this would be 7x squared when I add those. And 6x minus 8x would be negative 2x. And there is my answer. That's what I get when I multiply those two polynomials. Okay. All right, let's try another. So got a binomial here. So I'll put x squared here, and I'm going to put the negative 3. That's the second term. Okay. And then I've got a 3x squared for the trinomial, then a 5x, then a negative 1. You could put the plus there if you wanted to, but I'm just putting the value of the 3 terms, so I'm not worrying about putting in the plus there, because I'm just setting up a multiplication chart. Okay, then 3x squared times x squared would be 3x to the fourth. X squared times 5x squared would be 5x to the third, and x squared times negative 1 is negative x squared. Okay. And then here, negative 3 times negative 3 times positive 3x squared would be negative 9x squared. Negative 3 times 5x is negative 15x. And negative 3 times negative 1 is positive 3. Okay, now looking at this, I'm just kind of scanning all these terms. I've only got 2 terms here that are like terms. Those 2, right? That's the only ones I see, okay? So I've got the 3x to the fourth. Let me put my x to the third term next, kind of just putting them in order as I go. Then I get the negative 9x squared and a negative 1x squared minus 15x minus plus 3. Okay, and then I just need to combine those 2 and I'll be finished. And if you're drawing your own boxes, sometimes the boxes won't be drawn for you. It doesn't matter. You could put the binomial on the left, or you could put the binomial on the top. It doesn't matter. So you could put the trinomial in either position too, right? You just want one of your polynomials on the left side and one on the top side, and it should work out. Okay. All right, let's try a couple more on the next page. So now we've got larger problems because now I've got a trinomial times another trinomial. So I'm going to put this first trinomial down the left side, just the value of the three terms. And then I'll put the other trinomial along the top. Value of the three terms, and now I just do all the multiplication. So 2x squared times x squared is 2x to the fourth. X squared times negative 2x would be negative 2x to the third. X squared times 3 is 3x squared. Okay, and I keep following the same pattern. Now I'm going to multiply all of these by 3x. So this would be 6x to the third, negative 6x squared, and 9x. And then I'm multiplying everything by negative 1. So in this bottom column, it's just going to change the sign of those three terms then when I multiply by negative 1. Okay. And now I'm going to add everything up. And just scanning this for like terms, I got those x to the third terms. Here's x squared terms. Here's x to the first terms. Okay, so let's see. Start with the x to the fourth. Then I'll do my x to the third terms. Just makes it easier to combine like terms when you have them all kind of next to each other when you write these out. Ooh, running out of space. There's my negative 3. Okay, so then, yeah, I'm going to be combining these and those. Okay. So 6x to the third minus 2x to the third would be 4x to the third. And let's see, negative 2 minus 6 would be negative 8. But then we add 3, so that's negative 5. So this is negative 5x squared. And then 2x plus 9x is 11x. And there is our solution. Okay, all right, let's try one more. So I'm putting the first trinomial terms on the left side. The other one I'll put along the top. Okay, and then I'll start doing the multiplication. So let's see, this would be 6x to the fourth, 10x to the third. Another nice thing about this method is that if you make a mistake, then hopefully you can go back and find where the mistake was. Just recheck all your multiplication, right? So hopefully I don't do that here. But okay, so 9x to the third, 15x squared, and 21x. Just a nice way to organize your work. Okay, then multiplying everything by negative 4. Okay, and you'll notice again the like terms are on these diagonals. Okay, so let's see. I'm going to write a little smaller than on the previous problem so I can fit this all. Okay, and then let's see. Those are like terms, these 3 are like terms, and those 2 are like terms. Okay, so 9x to the third plus 10x to the third, that's 19x to the third. And let's see, this is going to be negative 12 plus 15 would be 3. And then I'm adding another 14, so that's 17x squared. And negative 20 plus 21 would be 1, so that's just 1x, or just x, and then the negative 28. Okay. All right, that is the end of the section, and I'll see you next time.